Hello. Let me close some windows. I have too many windows. Close that. Close that. And that. Close Steam. Okay. Okay. Yes. Emitted. Okay. I just wanted to see if this was a syntax tree node, which it isn't. Okay. So what I'm doing right now, you know, we're going to do some more Bugsnax a little bit today. I need to re-aim my camera, I think, a little bit. I feel like it's pointing off to the side. But so we can do some Bugsnax today. But before I do that, I want to put in some time to make progress toward longer term plans. So one of my long-term plans that's kind of difficult is to refactor the compiler so that it is much more better structured for high performance parallelism. That's non-trivial. I did a little bit of it a couple weeks ago. And then that led to, like, it's funny because every time you want to restructure things, you start looking at it and then it's like, oh yeah, this other thing over here is kind of standing in the way of this restructure, but that other thing I kind of needed to redo anyway. So it sort of triggered one of those. And then that was this big polymorphism change that we shipped to the beta people. And that one's actually not even completely done, I guess. But it's still much better than it was. And so now I want to do another step toward that, which is I just want to review this file. It's a pretty big file. It's like 6,600 lines. And I just want to review it and look for things that are easy to refactor off the general data structures to be more compartmentalized in terms of this particular system. Right? Because especially when I'm starting to program something, I don't like to have lots of different things floating around. I don't like to have lots of different ideas I have to keep track of, especially when they're not the right ideas anyway. Like if you do this style of programming where you make a different data structure and getter setter for every little idea, like most of those ideas are not correctly aimed. And so a lot of that code is just garbage waste, right? And so one way early in a project that I have of minimizing that is just by like minimizing the number of concepts I have to deal with. And then later on, as I know things are the right concepts, I maybe don't mind adding more. And so the core data structures of the compiler are a little bit overloaded. So like the syntax tree nodes, they have stuff that you would expect to be on syntax tree nodes, right? Like the things describing where they are in the program and stuff. But then they have like type checking information. They basically get used as scratch pads for all these different systems to write in, which is actually a very convenient thing to do for a while. But if you want to parallelize them and separate them out later, then it's not that good of a thing to do anymore. And so it's sort of like we're sort of leaving one phase of a certain kind of organization being appropriate and entering another phase. And I can do that one subsystem at a time. So right now I want to look at the bytecode system and just sort of figure out, not even necessarily fix 100% of those things, but just like figure out the easy ones and do them, because the more weight you take off, like part of what happens when you try to do a real big restructuring like that, as you start doing it, and then you're like, oh man, in order to do this, I have to do this. And in order to do that, I have to do this. But this thing, if I had realized in the beginning, I could have done, like, let's call it thing C, like A required B and B required C. And C, I actually could have done independently of the whole big restructuring anyway, because it would have been nice to do, but I didn't realize that. But now that I'm doing it, I've got this big edit going where I've got a ton of A happening and a ton of B happening. And I could do C, but then I can't really check it in because I've got this huge munged up code base from A and B. But if I had checked in C, then A and B become easier, right? And so a couple times, actually this happened a few weeks ago, I started doing that. I found something C that was good to do. And then I reverted everything else. I reverted like 2 hours of menial source code changes so I could do the compartmentalized thing and check that in. So that was good. And it made me realize that I should do a few sweeps for stuff like this that are easier low-hanging fruit first. Are there any questions about that while I go aim my camera? Is this where we go full academic compiler design? No, we will not ever go full academic compiler design. I don't know. I guess the camera's fine. It looks like it's pointing in totally the wrong place, but when I go look at the image, it's fine. I mean, when I sit up, I'm a little bit uncomfortably high, but then I want to slouch a lot. I don't know. I don't know how to solve these problems. Maybe I just need to edit, like crop off the sides a little bit and have the camera be further back. But when the camera is further back, it catches the top of my monitor more readily. I could put it higher up, and then that's a weirder angle. I don't know, everybody. On the fly, font rasterization, does that mean drawing each full string into a texture each frame instead of per glyph rendering? How do you deal with long-lived strings versus ones that change per frame? I mean, look, 3D rendering is all about doing tremendously expensive things every frame. So if you're already doing that, what's drawing some text? Who cares, right? Like if you have any idea how expensive it is to render a scene of, Call of Duty Warzone, who cares about some text? Like, so optimizing for text that doesn't change is a little bit silly. How am I currently thinking about metaprogram use cases that introduce non-determinism? Look, if you as the programmer introduce non-determinism, then that's your problem, right? It's very easy to do that. Okay, well, here's the thing. The definition of a high-speed parallel program is that there's non-determinism. It may not be non-determinism in things that you care about, right? Like maybe you want everything to join correctly in the end, and then you sort your results and stuff and you get deterministic results. But basically, parallel programs have a great deal of undetermined and inconsistent things in the middle, right? In the middle of the transactions. And so like having some idea where you as the system maker are supposed to prevent that means that you can't let people make high performance programs in some way, right? So that would be silly. So it's up to people. Can someone who doesn't major in a STEM field be good at game programming? Look, college doesn't matter. College is a stupid waste of time, honestly. College is a fake way of gaining social credentials. That's what it is. These days, college used to be something better than that, but these days, in the year 2020, that's what it is. It's all fake. Do I do much architecture design or just do work on the next thing that's important? I go back and forth between those. What parts do I think are the hardest to parallelize? The type checker. The power you get as a user with the metaprogramming is worth it. Yeah, but what I'm saying is like if your friend was taking the opposite tack, your friend has a fundamentally misguided idea about programming. Like maybe if you're making a language for non-systems programmers, you want to avoid non-determinism, right? Because like if it's like Logo or something, if it's like an educational language and you're not trying to be fast and you're not trying to make production quality software in it, then sure, like try to minimize bugs by putting guardrails everywhere and like training wheels on the bicycle and stuff. But like, you know, you're not going to win the Tour de France with training wheels on your bicycle. That's just not a fucking thing, right? And anyone who doesn't know that, anyone who thinks they should go compete in the Tour de France with training wheels on their bicycle, just clearly has no competition experience. Now, clearly you can make an argument that they should, because look, if you fall over during the race, that's really bad, and the training wheels will keep you from falling over. Yeah, it's a mistake to even think that way. Do people even know, are training wheels still a thing? I assume they are. I just know what people had on bicycles when I was a kid. Floating point is a good example, yeah. I mean, floating point error is not strictly non-deterministic, but in practice it is. By the time you add it to some other assumptions about what your compiler is allowed to do, optimization-wise, for example. Are graphics drivers still a major problem? Yeah, pretty much. What do I wish Intel, AMD, NVIDIA did about it? I wish they would delete all the graphics drivers. That said, we haven't shipped a game in DX12 or Vulkan, so maybe that situation is better. Is parallelizing type checking hard because merging multiple intermediate results becomes more difficult? It's hard because it's about walking around the tree in order to figure out what type you are, and there's just a lot of like, hey, is the thing that I'm looking at, does it have its type ready or not? And all this stuff where, so first you have to come up with a model of how that works. Like maybe there's some boundary where you know when you're looking at things inside the boundary that are like in your thread, and when there are things outside the boundary, like, okay, that's fine. I still don't know exactly what that looks like, but I can imagine that. But then there's just like the fact that there's all this complicated code that uses a lot of variables and stuff that are shared with the rest of the program, and like C++ doesn't help you with any of that stuff at all, right? Like C++ is ass at starting with a single threaded program and making it multi-threaded. So I just have to figure that out. That's the real problem, is just the complexity of the code. Can you ask a font rendering? No, I don't know anything about font rendering. Okay. Could right repair laws require them to give out enough information so you could write their own driver? I doubt it, but even that just makes the problem worse. Now there are even more drivers with even less effort per driver. That makes the problem worse. We have to redesign the system to not require drivers in the way they are currently required. That is the only way to make it better. Open source people are not going to fucking solve this problem, because it's that open source is even less reliable than graphics drivers. So like, what are you going to do there? Right? Last UI fixing stream, I said never scale a font. But render target size. You're wondering, well, okay. If you render a font to a texture, for example. Okay, there's two ways you might end up scaling a font. One is you render your particular glyphs to quads, right? And then you draw those quads scaled to resize the font. Don't do that because you get blurry text or alias text. You want to rasterize the text at the same resolution, 1:1, pixel to pixel, that it will appear on the screen, because that's how you get it to look good, right? The other way that you might end up scaling the text is, 3D games render to an off-screen buffer and do some post effects when they tone map that and scale that to the front buffer and stuff, right? And so if you do text into that off-screen buffer, it'll get rescaled as it goes to the front buffer, and that looks bad too. So you don't want to do that. Remember when Carmack was creating mega textures, he ended up creating a job system which inadvertently made the engine super multi-threaded? Thoughts? Well, it sure took them a long time to ship Rage. Also, I'm not a fan of complicated job systems. Just like I'm not a fan of complicated anything. I don't know what the Rage one looked like. But I'm not a fan of these like GDC job system lectures that have happened recently that everybody is high. It's going to be like the new entity component system, and like I don't think there's a point to any of it. Yeah, that's true. So fonts themselves, someone's bringing up the point, fonts themselves have hints inside them about how to render them differently at different sizes also. So if you're going to make a very much smaller version of a font, like it's just going to look different. Like the rasterization is going to do different things. So that's another reason not to scale fonts, because you're not letting the font designer do the work that they're trying to do to make it look good. Is a build system planned? Yeah, you've definitely missed everything about this programming language. Is entity component system useful in certain? Entity component system is useful when you make a game engine and your customer is the person making the game. That is the primary situation in which that is useful. If that is not your situation, don't build one. Okay, let me actually try doing some of this work. Every MD has all the data. I mean, that's maybe a little bit extreme. But there are reasons to do that. There are benefits to it. Okay. So I'm just going to I'm looking at the code for things that use the syntax tree nodes to store data. And I already changed one of these things today. So this stuff is all the stuff we did when we were improving our Weissman score. It uses data structures stored on the basic blocks. So I don't think it's really going to have this kind of issue. But I'm still kind of looking at it, glancing over it. This is all still Weissman score stuff. Okay. So now we're starting to get into territory. Actually, this is just a function I rewrote today. So we know those are good. All right. So we're 10% of the way through the file. That's great. Okay, get binop from token. That's just a function. Allocate output register is a number, is an integer, is a procedure. Emit code to push Sentinel stack trace node. Yeah, there's no reason for that to store anything on the syntax tree, I don't think. The other thing I could do is I could do this search in the other direction by looking at the syntax tree nodes. Let's do that. Because this file is only 2,000 lines, and I mean, a lot of it is enums, right? So I can just look through here for bytecode builder related stuff, which the downside to this approach is I might not notice it going in this direction, but yeah, none of this is a problem. This is, so after I do this pass on the bytecode builder, maybe on a different stream, we can do it. We can get rid of this exported. If we can do that quickly, because this is, so we eventually want the syntax tree node to be just syntax, right? And this exported includes the type information. And even if we don't move the type information and stuff, we can remove the subsystems, and it decreases the number of constraints that are holding things in the current structure. Okay. Only 2,000 lines. Look, we're already 250 lines through the 2,000 lines. Okay, scope entry. This is all syntax stuff. That's kind of semantics. Overloads. Okay, so there's nothing here that is past type checker. Nothing there that is past type checker. I would expect this to be the case. Bytecode system doesn't really need to do a lot on the tree nodes. And in fact, it might not be doing anything else. But I'm just doing this sweep just to look. Yes, using identifiers. Unary operator. Yeah, I'm not seeing anything yet. Call resolution status. Right there. Result register base. It's quite possible that we can put that somewhere else. Let me put this down at the bottom of the thing. So what happens is we know we need n. These are actually value numbers, not machine registers. I'm trying to change that terminology in the compiler. Like I call them registers, but they're just like bytecode. They're bytecode registers, not machine registers. And like that's having the word register mean both things is a little bit confusing probably. So what happens is when we're returning things or evaluating a macro, which is like pretend returning things, we just know that the nth return value goes from this base, right? So the question is, if we put this, okay, so there's like 8 uses of this in the file, and some of them are assertions. Can we put this somewhere else? Like, can we put it on the bytecode or like basically, okay. Anytime that you have like a data structure that has a field, you can of course factor your program such that you have a separate, like an array or any kind of association that has a pointer to your structure and a pointer to your, as long as the data structure doesn't move, some way of identifying the data structure and then some way of identifying the value, like whether it's a hash table, an array, a linked list, doesn't matter. You can always factor your program back and forth across that. So what I'm thinking is right now, is there any very convenient factoring that I can do on this? But also I want to go change the temperature in my room here. So back in a second. Are we finding it easy to interface with existing C++ code in libraries? C is pretty easy. C++ is annoying. C++ is doable, but it's a little bit of a hassle. Okay, so here we're emitting a return statement. And it's, is this a return inside a macro or not? So we're actually gonna use it again down. Really, we don't. That's weird. Oh, because the return instruction. Oh, I see. Okay. Yes. Okay, so the return syntax tree node says it translates to multiple instructions. So if it's not a macro, it says poke return value for every return value, right? And then go. Now, poke return value doesn't need to know this. And the question is, why not? It gets that from there's like a call record or something, poke return value. So we get the index and I mean, I guess we just know the calling convention here. Return address size. Yeah, so we just know it's 8 bytes per return address. So we just index into the memory right there, or per return anything, right? Okay. So really, in this case, we only need this for a macro. All right, let's look at the other cases before I rat hole on that. We're looking for return register base. Oh no, arrow return register. Wait, what was it called? Why am I so confused? Result register base. Result register base. Okay, so that's what we were just looking at. Here, when we emit the macro expansion, we return the register base. Oh, because the implicit, when you do a procedure call, its expression value is the first return value. And so that's what the base is for there as well. Oh, you know, this like macro argument registers. I see. Okay, this is another thing that's happening in bytecode. I thought for some reason this was in type checker, but it's not. So like both of these things are things that we are looking to remap right now, if we can. Okay. Well, okay, let me keep, we were looking at result register base. So that's used in macros. This is allocating the actual registers we're going to use. And this is actually really gross. We just make them in a loop. But, you know, how many return values do you have? Not that many. So it's fine for now. So actually, we have this push procedure call for emit memoization. So we may be able to use that data structure to do this already. This was a thing that we added for Weissman score purposes. But what it tells us is what procedure calls are we in the middle of emitting, right? And so if you wrote a really deep nested procedure call, that might be annoying, right? But normally, this is going to be like one or two or three things deep. So looking in here to get this value is pretty straightforward, probably. We'll take a look at that in a bit. Let's continue. So this is where we create that, right? And so then we pop it at the end, and that has done all these things. So everything that uses this should be in here. Okay, result register base. And then down here, oh, extract. Okay, this is the part that might be hard because this happens after we return from the call. Like, we need to know what register that result went into. Okay, this is the one that looks annoying. Now, we can leave that member on for a little bit and convert the other ones, and then try and figure out what to do about this one at the end. Maybe that's smart, maybe it's not smart. The thing that's not smart about it is, what if the thing that's good to do for this is different from the thing that was good to do for all the other ones, and then we have to change those again anyway, right? The thing that is smart about it is, maybe in converting all those other ones off this old way of doing it, we discover some problem that I don't currently realize, and that helps inform the decision better anyway, right? So who knows? Like, sometimes you just do it one way and that has one set of consequences, or you do it the other way and that has another set of consequences. But so what's important is actually do it some way that's not totally stupid and just put in the time and do the work, right? That's what I think. Do you do tail calls? No. Tail calls can go jump off a cliff. Stop going to Lisp school, please. Stop going to Lisp school. I swear people are going to ask me about this every day now for some reason. Why does it always tail calls? I don't know. Tail calls are the entity component system of April 2021, even though tail calls have been around since probably the 1960s. One Hacker News. Is that what happened? There was a tail call story on Hacker News. Okay. Yeah, it's like, look, yes, you can find cases where tail calls will make your code run faster if it was written in a Lispy style. But guess what? The fast way to write code isn't in a Lispy style to begin with. So if you do that, you don't have this kind of problem anyway. The end. Have I seen the anti-if campaign? No, but I'm sure it's very smart. Let's see the anti-if campaign. I mean, it's true that if statements are an indicator of complexity. But like the question is that complexity helpful or necessary? or not, right? I suspect that this goes down the road of let's get rid of ifs by like dynamically dispatching to objects or something, in which case you're just obfuscating the complexity and you're actually making it worse, right? That's how most of these things go. Yeah, that's exactly right. Do you want your crappy recursive code to run as fast as the code you should have written in the first place? Tail call optimization. That is exactly correct. Now it is, so sometimes it is legit to write recursive code. Sometimes that really is the best way to do something. Not nearly as much as people who went to MIT or Berkeley think it is. And in those cases, surprise, surprise, tail call optimization doesn't help you because you want to call the function and then do something with the result after that you call, right? The only case tail call optimization helps in, by definition, is when you don't want to do anything with a result of your recursive call. How frickin' often is that if you're writing actual code that does real work? Okay. Okay. So how am I going to do this? We were going to look at, wait, was that? Yeah, that was the last result register base. So this one, I'm not sure what to do. The thing, let me get out a piece of paper. So thing one to do is to check whether we actually even do this anymore. I think we do. I think we do, but there might be a different way to deal with it. Like we could just flag the call that it gets an extract and just put it in an array somewhere. Like it's something stupid like that. Okay. Emit return, right? So this was doing the equivalent of poke return value. This is just doing register to register moves if it's a macro as opposed to poke return values. Okay. Here was, again, the macro expansion return value, expression value. Here was this push procedure call for emit memoization. So, yeah, this basically adds a record onto the emit procedure stack, right? So we could just use that. This stack contains all active calls while we are generating bytecode for this procedure. So yeah, I think we can do this. And this should be the only call to this function even, right? Yes. So look, I factored like 6 lines into its own thing. Why? Because I just wasn't sure how to think about things the most clearly. Okay. Let's change this return value. Wait, starting basic. Oh, we don't even use that variable. So, because I wanted to change the return value. So the return value from this is actually going to be the call record, or I don't know what type this is. It's some frickin' type. I guess I need to know to return it. Emit procedure stack. Who has this? Emit procedure stack. It's on bytecode. Okay. Emitting call. All right. Calling it record is a little weird, but all right. I'm going to do this. So we have emitting call. And only need to do this if args.count greater than 0, no longer true. No longer true because we're going to use this to store other things. All right. And see, this is a little bit scary. Oh, yeah. There's reasons why this is scary that I don't want to go into. Anyway, so we could say emitting call result register base. Okay, so the goal is to get rid of this one, but right now we're going to put these two in parallel so that we can just switch from using one to the other gradually. All right, so where is that? Well, emitting call. Let's call it result value number base, right? In the spirit of moving the terminology. And let's just see that compile. Whoops. The apparently are Turing complete, but only using move instructions. Yeah, I mean, this is again an academic thing, but one of the things I learned in school was you can compile an entire programming language into one instruction. The subtract and branch if negative instruction is Turing complete, right? So, you know, it takes two value number arguments and then one branch target for every instruction, and you can compile any program into that. So you don't even need like a variety of moves. And then I guess the first register is also a target, because you need to be able to modify values. So the first register is like a target value, and there's like some proof that that's Turing complete, right? $7 hours per frame. I mean, imagine if it had tail calls, it could be down to 3 hours per frame instead of 7, right? I'm honestly not that interested in putting web people on the compiler beta. Sorry. Web people can get on it later when it is open beta, but like, it's just not, it's just not what I'm making the language for. So XOR is also Turing complete. Yeah, I guess that makes sense. What do I think about people saying you should avoid big complex else statements and instead use state machines? I mean, look, if the state machine is simpler, use it. If it's not simpler, then what are you doing? I mean, to me, state machines seem very complicated, so I'm not sure what they're talking about. Okay. Anyway. So we compile. That's great. We could even, was that debug build? Yes. I keep going to the wrong windows. So let's just make sure these things build. Whoops, that's release. Let's do debug. And we're just making sure I didn't break anything. Like, I didn't do anything serious, but it's been almost an hour that we've been like chatting, and so who knows if I absent-mindedly did something, right? Okay. Now, though, we can, anytime that we're using this, I can instead say find emitting call for the call, which you have to find it because it might not be the one on the top of the stack. Probably. Is that true? Actually, I think it's always the one on the top of the stack. I'm pretty sure it actually is always the thing on the top of the stack. Let's write a getter as if we didn't know that was true, but then we'll assert that it is true. Because that makes it extra fast. That's great. If it's always a thing on the top, like I said, the stack's never really going to be very deep for real programs, but if it's trivial, it's trivial. That's great. Okay. So let's check this. That passed. That is doing great. We are all happy here. Okay. So well, we can start using this thing. So everywhere we see result register base. Oh, and in fact, down here, I could say the following. I'm just making a local variable for this because we want to return it and like pass it to things, right? Like here, result value number base. And here, we're just cutting down on, and this is just like, yeah, I don't know. These guys are going to fill those out. Yeah. And I'm just going to be real conservative and run these tests again. I probably won't wait for them to complete, but we can at least tell if we broke something. All right. All right. So that's great. We're still setting this old thing, but using it less. Okay, so here's a place where we need it. This is the one that we don't know how to handle yet. This one we can handle. And then these ones. So this was the macro expansion one. I think with this one, we can just pass it in. Hold on. Like here, nobody else calls this. So it's stupid. Like we know what the result has to be. It has to be this. So like, oh, I guess it doesn't have to be. I guess we could do an optimization at some point. We can think about this harder later. I think see the way this is set up right now is it just returns the thing that we already set up over here. So like it's kind of stupid because we're the caller anyway. We know what that is. It's important to get rid of spaghetti like this from a program when you can. However, I think the reason I did this originally was I was like, well, later we can elide copies within this thing by returning a different value. But you know what? That's a concern for another day that's far in the future. And I think we worry about it some other time. And in fact, we don't actually return anything from here because like it's the actual return statement generation that we were looking at that would make that decision anyway. That's not even connected to this function. So yeah, we're just going to do this. So we're going to do this and then say return result value number base. Okay. How'd this go? That went great. We're going to run it again with these new changes. We're just going to keep that going in parallel. Parallel. All right. So, what was this variable called? It was called result register base. I keep forgetting. Result register base. Okay, that's the extract. So there's still two sites that still use it. So there's this emit return and this emit procedure call, which is setting it. Okay, so that's it. There's the extract and then this emit return. So here we could say okay, and then assert emitting call, right? On this data structure, it's result value number base, and that goes here. All right. Wait, what? Yeah, I'm pretty sure this has to be the top one. Let's say. What is it called? Emitting call? Yeah, emitting call, find emitting call. So we're going to go auto const and stack equals builder emit procedure stack assert stack.count is greater than 0 auto peak assert emitting call is equal to call. Maybe this isn't true, but I think it is. I think it's true 100% of the time. Okay, return emitting. So that's kind of trivial. Emit procedure stack. Oh, it's bytecode. Did we say current bytecode? That actually could be on the builder. I don't know why that's on the bytecode exactly, but it's fine. Maybe it should be on the bytecode. auto emitting. Oh. Dude, C++, bro. Okay. It's not called... Oh, we didn't store the call on here. I guess it's site. Emit procedure stack. Okay, so this is always a call right now. We're just going to make it a call. And that thing that says it's not really used, that's not true anymore. All right. Probably still need to change some things. Yep, 398. This is just making sure when we pop that we didn't get confused. 8 call. It's like the 8 ball. All right. Okay, result value number base. Number. Is it possible for libraries to define their own metaprograms? Sort of. But they're not. Like, you can run compile time code. It's just not authoritative in the same way right now. Unless, like, you can establish a convention for what other people should do. But no, we don't have a thing where they just magically start a main loop and then you have to fight with it. That's not a thing that happens. All right. Well. Okay, so we just have this extract thing. Extract is, it's in the syntax tree hierarchy, but it's not really something that user level code has syntax to generate. It's a thing that we made when, for example, desugaring declarations and stuff. Or actually when we return multiple values. That's actually kind of how we do it, is we just say, you say extract the third return value from this procedure call or whatever. Oh. Wait. I think, okay, I don't think this has anything to do with what we just did. I think this is a Heisenberg that I'm not going to rat hole and fix right now, even though we want to fix it. I think if I run this again, it has a high probability of passing. But we do have a thing where our builds fail right now for unknown reasons, and it's something like that. Let me at least write down or screenshot this information so I can look at what's failing, because that might help me repro it as well. So we've got that for later. But I don't want to rat hole on it now. Yeah. Okay. So that is a thing. Someone is going to be looking into that, I believe, who is not me. We'll see. Maybe I should just do it later today as well. Okay. Anyway, so the last thing is this extract. So this just return this register might be old. Let's just see who makes an extract. There's 3 sites that make them. Okay. Okay, yeah, this is a comma separated assignment. This is macro expansion for some reason. So I think it's return values the same way. Although I'm not sure why I'd do that. Because I thought the return from the macro already. Oh, the return from the macro does one register to register copy. We copy in and then copy back out. And we're relying on, yeah, okay. Okay. So this is the same thing. It's like, give me the return values. Except, why are we doing this over all the arguments? Oh, it's is from macro arguments, I guess, makes it do something different. We'll look at that. And then this one is, again, it's a multi-value declaration, I think, right? Yeah, compound declaration. And mode extract is what happens when we have a procedure call on the right. Or something that could desugar into a procedure call. Because these could be custom operators, right? Okay. So we do still use this. That's all I was checking. I was just making sure. Okay. Yeah, so this is, hey, if it's to pull from the macro arguments, then we do this. Otherwise, it's the result register base thing. Okay. So we still have to move the macro argument registers as well. So the question is, do we finish with the result register base, or do we move the macro argument registers? I think we finish with result register base. Okay, so now here's what I think. I believe that I get a get out of jail free card on this, because I think when we do an ast extract from a call in the bytecode, I think it is not possible to have another call between the first call and the extract. And that's something that I'm going to assume, and then we'll put an assert. But I believe that in the same way we looked on that stack, well, whenever we looked on the stack, it was always the most recent one, right? I believe, so the problem is we pop it off the stack, right? But when we pop things off the stack, because we're done processing the call, we could just say the most recently processed call is this one, right? And I believe that if we assert here that is the right one because we can compare this call pointer again. I believe that that will be correct. And then we can just use that in the same way. And so we would use that down here for result register base. And then that would get rid of that variable. Let's make sure our tests, yeah, they were good. They were good. All right, so I'm going to say emitted call is get recently completed call from the bytecode and the call. And that's going to assert if it's not what we think it is. And then we're going to say here, it was emitted call, what was it called, man? Result value number base. I should just call it return value base. I don't know. We can replace, because this is a unique variable name, it's very easy to global search and replace it, right? Okay. Emitting call. Emitted. Okay. Anyway. So now we're going to do the following. Get recently completed call from the bytecode. And we're going to say, wait, where was our... This one, fine. I wanted to put it with this. Get recently completed call. Takes a bytecode. Okay. That's all. We're just going to do this. So when we pop one, actually, let's put these next to the other things. Like these all go together here. When we pop one, we're just going to copy that control, and then it's in this header file. Okay. Okay. Maybe that'll work. Maybe it won't. All right, 400. Illegal indirection. Oh, record. I guess is by value. Okay. Okay. Would I use something like IntelliSense if it was lightning fast and worked with my Emacs setup? Maybe. Like define IntelliSense. I'm working on eating sun chips and not answering people who want me to repeat myself 50 million times every stream for everyone who shows up and doesn't know what's going on. Okay. I believe this means we can now delete that old variable, one of them. We should be able to delete result register base. All right. We have this. That's the declaration in the data structure. We have this thing that we were maintaining for backwards compatibility, and then we have these things that are commented out. So if I delete that, and I delete that, and I delete these, and we retest, then we're pretty good because we got one of the things off the syntax tree. We still want to get macro argument registers off there, but that should be very easy by the same things that we've already done. Very easy. Code auto completion for stuff like struct member names, local variables, function parameters. I mean, how annoying and shitty is the autocomplete? Like the Visual Studio autocomplete is awful. So like it would have to be reliable. Like Unix shell autocomplete historically was good. These days, I don't know. I feel like the kids fucked it up. But historically, like TC or something had really good autocomplete that you could mostly rely on at least. But like the whole problem is as soon as you're in a loop of you have to look at the screen in order to understand what you should type next, that is massively slow and taxing on your mental facilities. So like you think autocomplete's helping you, but in those cases it actually is not, probably, I would say. I was carrying these sun chips in a backpack to various places. So now I've got like a corner bag of broken sun chips, which are still good, but harder to eat. Did I run these after deleting that variable? I think so. Anyway, that's good progress. So next, we do this also with emitted macro argument registers. So we're just going to do this here, and we're going to do this, use it here. Well, let's double check that it's not hard to do it here. No. So this thing sets up this array, but we could just pass the emitted call in here. And then that's it. That's just there, and then here where we're using it. So all right. So we're going to go here. We're going to get rid of macro argument registers. We're going to call it value numbers for now. Oh, this is an array of value number. Macro argument value numbers. Okay. All right, and then we're just going to pass that in right there. And just start a rebuild, which won't succeed yet, but it'll get all the headers and things. Let's check our, okay, that's all good. So we have our emitting call and, well, I think that's it. Like that's, oh. All right. Someone's still trying to use this. Oh, emitting. GG's. That seemed like it might have been hard, but it was not. So now we have achieved greater separation between these two systems, which is one of the bricks in the wall. Oh, except I fucked it up. Oh, guys. Right. Here's the thing. We don't push. It's not quite GG's yet. It's not a big deal, but when we do a macro expansion, Actually, I don't know. Wait, what? What? This is not true for macros in the way. Okay. So we're at extract. Oh. Hmm. Maybe we have to put more of a data structure here if it's a macro for some reason. I'm not sure why. I was calling it a little early. It really happens all over the place, so this is probably to do with for expansions or something. The fact that it happens basically everywhere is nice from the standpoint of not having to hunt down the problem. Probably have lots of breakpoints we don't need. Let's get rid of these. Man, this program's so slow. Visual Studio. All right. Great. Okay. So, whoops. Can't type. Oh. Oh, yeah, because, okay. Right. No, I was thinking this, and then I was looking at the code. We do not push and pop this for macros. I don't think. Because emit procedure call here, oh, maybe it is. Hold on. Hold on. No, we do. We say emit macro expansion. Are we somehow emitting an extract before we do this? Or what? Like what? What is the problem? Ah. Pouring the tea now. We have warm tea. Okay, so why is this happening? Like literally, this is blank, which means within this bytecode, hold on. Yeah, so we're emitting from a procedure call. Oh. Right. No, I don't know. I don't know. I don't know how we get to null. That's the weird thing. Like how, like I understand how, okay, maybe we did the procedure call and then we went on later and we did the extract and like whatever, whatever. But that would leave an old value in emitting that was just like for a different call. Oh, we actually, here we go. Emitting. Like this is, we actually don't initialize these things, but they're all 0. Okay, so we're in the middle of this call probably, right? So call is OAO, I see. So the deal is we generate this instruction while we're in the macro. Okay. So we need to do this. Here, I was trying to be sly and share this, but this one needs to be the one that we're in, which is this one. Which doesn't really matter. Like those operations are the same speed right now, approximately. Actually, it's a hair slower. All right, yeah, so that was no big deal. It's just, I didn't understand that that extract happens inside the macro, not outside, which makes sense because we're copying the arguments in. It's kind of an abusive extract. It's one that I added when I implemented macros. And that's what's confusing me is I'm using something in a way that I'm not used to thinking about it. But there we go. So that again, GGs, I prematurely called GGs, but that is real GGs right there. We got rid of all the things there. Now there might be other bytecode stuff on other data structures. I'm going to keep looking. I don't see any yet. Okay. This one is hairy, right? So like, I don't even want to look at that yet. But like the just return this register. Does anyone set that? All right. So we have succeeded. We can and probably should check this in. Because that's a decent cleanup. Literally nobody ever sets just return this register. Which is good, because otherwise that would give us something to clean up. So we're going to get rid of that. We'll do that in a real text editor. Hold on. A quasi-real text editor. A text editor that I wish was more real than it was. Okay, so we're going to delete that. Move that. Delete that. Okay, so that's good too. Okay. So nice. We just got another quickie. How we're 500 lines through. Expression error placed. Polymorph depth. Okay. Here, Lambda has some stuff from the back end in it, which we maybe also want to get out of there. Okay, bytecode being on Lambda, that's maybe not great. We could look at that. Although, honestly, maybe we don't want to change that right now. Like, that's the sort of thing to change later on when we like actually factor these things apart, maybe. See, all this is like back-end Scratchpad stuff. There's just a bunch, like Lambda is kind of a dumping ground, honestly. All right. So I've written that down, that's a thing to think about. All right. How's this? Problem is we can't put this in the changelog because it's not a user visible change. Okay. Great. Great. Remove some bytecode system stuff that was stored on AST. Look at that, just 4 files. That's all. That's all we did. Okay, so even that would have been enough for the stream. We'll keep going, but that was a good accomplishment. Oh, did a raid just happen? What happened? Oh, hello raiding people. Welcome. We are making our program better. We're going through and just cleaning up things in it that could be better. Because everything could always be better than it is. That's the wonderful thing. Okay. It implies a replacement of design. I don't understand that criticism. I mean, if you're talking about design of the program, then of course it's a replacement of design. What do you mean? What do you even mean? What do you even mean? Okay. This is backend stuff. That's LLVM backend stuff. So eventually we're just going to want an index for these. Like when we generate a Lambda on in the front end, we could have a serial number or something. I mean, the problem is, of course, if you want to be parallel, serial numbers are not good, but you can have an augment, you can have a double serial number, right? You can have like thread and then the other thing, and you could use that to index a parallel table, for example. And like that whole system is a thing that we're going to want to work out, but that's where you would put this kind of data and this kind of data. And we just don't have that yet. So I'm going to ignore that one, but I'm writing it down. Since Lambda is such a dumping ground, that might be a good place to start that stuff. Okay, so I'm just still looking through the file for more things. Statement debug infos, Lambda body. Okay, so this one's a little weird. Okay, so Statement debug info has offset in text section, which is used, well, by the backend. Probably just the x64 backend, right? That's also here, but we probably... I'm just going to write this one down and not... because I'm not sure that I'm that worried about it. Lambda body, statement debug info. Offset in text. Okay. Looking through structs. Module parameters. I don't see anything there. Maybe there's something hiding in struct member assignment. Nope. Nope, nope, nope. Okay. While if case okay, yeah. So case has some stuff. Everything from here and below, this is all bytecode system stuff. So again, this is solvable via the same kind of thing that we did. Although actually, maybe this gets set earlier than bytecode, but it's still something we would want to move off eventually. Okay, not going to dive into that yet. I'm in the mood to just survey right now. Okay, syntax tree, syntax trees. Okay, these right here. These are value numbers, just like the ones that we had been doing. And I'm not really sure that they need to be there, honestly. Okay. Anyway, so we could move those off. Those seem like the easiest ones, but you never know. All right, we're going to keep looking. Yeah, that's fine. That's fine. Type definition. Oh boy. Oh boy. Yeah, I don't see anything there. Maybe I'm missing something and being dumb, but I don't see anything. So these linear allocations are things that we're going to want to move, but these are not, those are not bytecode. Those are a different system. We're not trying to do all the systems right now. It's like one way to keep sane is to not try to do everything at once when there's a great deal of stuff to do, right? Okay. Literals. Yeah, this is again, this is like a back end thing. We're not doing back end right now, but that is something we would be thinking about. Compound declaration. I think string literals are going to get like an integer index or something anyway. I don't know. Declaration. Yeah, nothing. Nothing. Enum. Scope directive. Module parameters. Foreign library. Name mapper info, which is currently unused even, I think. Directive load. Kind of wonder what's the deal with that. And now we're down to functions. So we might be done. Oh, no, more things. Okay, that's not bytecode. That's not bytecode. No. No, no. No. Okay. I think we're done looking for it. So there's not that much more. There is a bit more. And some of it not that obvious. Okay. So let's look at this list register, index register. Ooh, it was more than I thought. All right. This is BS, by the way. Okay, that should definitely not even be happening. So we just made gains of 2 lines of code. Come on. Come on. All right. So now we only have, because we got rid of these, we only have things in bytecode builder, which is great. Let's go look at how that's used. So when we're removing from a for loop, right, you can only do that inside a loop. So the same way we have a stack of active call stuff, we could have a stack of active loop controls. And I'm pretty sure we already have a stack of active loop controls anyway. Or loop, not loop controls, but loop loops. Actual loop-de-loop loops. Like for loops and stuff. So we could just look up that stack. You could imagine really pathological code where that's kind of slow, but it's not like you're doing it for most things. You're just doing it like when there's a remove or whatever, right? Okay. So list register is there. Decrement array length, that's also from the remove, right? Decrement. Yeah, that is literally the only place that's called from. So right away, we could just pass that in. Right? Yeah. Okay. So right there. And honestly, why is that even in its own function? Because I guess we thought, okay, you know what? See, we already have list type up there. Okay. This knowledge token thing, like, I think I used to do this because we didn't have a load plus offset, but now we do. So it could be, this isn't even the right fucking knowledge token. Okay. Okay. So like, literally, it turns into this. Approximately. Hope I didn't mess that up. Okay, so let me find list register here. I want to say list value. We're just going to put it right in one spot. Okay, that's a totally different function. So we should be able to do stuff. Okay, emit decrement array length. Oh, right. Emit decrement. Delete that. Delete that. Making gains. Making gains. Yeah. Great. Is it true that relational data normalization is important to DoD? I mean, they're kind of parallel concepts, let's say. It's not quite the same thing. I don't know. Like, the way the Unity thing does is pretty much that. But it's a very similar... I don't know. I don't really consider myself a data-oriented design person, so I shouldn't answer that. I practice ROD. or ROP, really. Okay, so that's been good. So that gets, okay, let's just review again. So when we remove, we want the list register. Now we've got it down to one reference to list register. It's right here. We create the list register when we start emitting code for the for loop. Well, inside the loop, right? See, this is kind of silly. Let's actually, because down further in this very function, we're dereferencing asked for list register, right? Which you don't need to do anyway. So this can be list value because it's just the thing that we did above. All right. Here, same. Like, I'm not quite sure how to know when I left this function, but same. Oh, and then there we do this. Okay. And that's it. So literally, the only time it is used is in the remove statement. Now, you can't just set something that's relatively global because you can remove things from outer loops, right? You can remove things 5 loops up if you're in a 6-dimensional loop. So it's, we have to maintain a stack of it, but like I said, I think we already do. So that's the next step, is to look for that. But I might just check this in, because that's fine, right? Snack-oriented programming, that's a pretty good one. All right. Okay, so I think, though, so when we do a scope close, don't we? Like, we say scope close loop. So we have to know all the loops. All right? Emit scope close. So here we say we've got this block stack. We do the defers. I see. That's actually not that good. Because that's just blocks. I mean, we could put other data in there, but we don't really want to most of the time. So I could just keep a stack of array-based for loops, right? And that's that. And that seems silly, but it is what it is. Now, that's only one of the two things. So that'll enable us to get rid of, did I check that in? I think I did, right? Yeah. Okay. So that lets us get rid of list register, but we still have like index register, which we haven't done. Oh boy, look at all that. Except I think that's for other things too. Okay, let me just try to get rid of index. I feel like if literally nobody uses this, we could just get rid of it. Yeah, like I think remove also uses it. Okay. That's literally the only place. So we just have to look this up. We just need a thing on bytecode, just like, yeah. Okay, so here's what we do. Emitting array 4. All right, and we're gonna say ast4 is 4 and value number list value number index value. All right, and then just like this, whoops, not there, array emitting for what was it called, emitting array 4, because we don't need this for all for loops. Just things that could be removed from. Literally just to implement remove. Okay. Okay, so first we do this. We don't need it, right? You can't, like, if it's got a macro expansion, that's something else, so we ignore that. We do all this stuff. List value. Okay. How do we do this? Wait, what? Why is loop body basic block hanging out up here? Let's move that guy down. Okay. There's this thing that happens where Brownian motion happens to code as it gets edited a lot, right? And like things, let's make sure that's still. For is a keyword, bro. For is a keyword. Don't you guys wish that I did the Pomodoro development technique and I could stop every 20 minutes or however long it is and eat 10 minutes of snacks? Does it have to be spaghetti sauce for a snack if you do Pomodoro? All right. Okay, so emitting array 4, we want to do this. So here we're going to go right? Emit for stack. Confusing names. So we do this and then we say emitting for arrow asked for equals asked for, emitting for arrow. Did we have list register or anything? No. All right. Anyway, so the reason we're doing this is we're going to say defer if emitting for current bytecode emit for stack dot pop. All right. Great. So now we will not forget to pop that. Yeah, this was a thing that I just did. So okay, so this is a no check-in. We're not going to forget to delete that, but so we're just moving these, you know. Where do we set this? Oh, it's up here. All right. So we could say list value equals list value. Okay, that's great. So we have these two things, and then down here we set the index if emitting for. And that's basically all the setup. So we can test to make sure the setup works. We're not using that value yet, but we only have to use it in one place, right? So that should not be hard. We could make a find emitting for function. Unlike the procedure call case, we actually do have to search up the stack. But the stack is not going to be that deep for most programs. It's how many array-based for loops are we emitting at once? So like you might do for somewhere once in your program and feel bad that you have a for nested loop or something, right? This is not a thing where there's going to be like 100. So if you don't know what decision to make, here's the thing. There are two legitimate, well, there can be lots of subtle differences, but there are two. If you're working on something complicated and you're like, I need to make some decision and I don't know which way to make it. There's sort of two major ways that that happens. One is I have a complete lack of information. And so I just don't know how to make this decision. Like I have no mooring to help me make the decision, right? That's one thing that could happen. The other thing that could happen is, well, I sort of know what's all involved in making this decision and I'm weighing all the factors and it's very ambiguous what's the best way forward. There's maybe some unknowns that are going to sway it one way or the other, right? And in both of those cases, the solution is the same. It's to just sit down and make an arbitrary decision and do the work, right? So in the case where you have no mooring with which to make an intelligent decision, then your goal now should be to get enough experience in that subject area that you can make a good decision, right? How do you do that? By working in the subject area. No excuses to that, really. If it's that you have a number of options and they seem close and you don't know which one to do, just pick one. Because if they all seem close and you pick a suboptimal one, it's not suboptimal by that much. Otherwise, you would have seen that, right? Or B, if something is suboptimal because of unknowns, then you didn't know the unknowns. How do you learn about the unknowns? You go into that territory and you do things. So literally always doing the work is the answer to those kind of conundra. And then the other thing to keep in mind is why might one regret, like, you might not want to make a decision because if it's wrong, the penalty seems terrible. And the goal there is just architect your work practice so that the penalty for making an incorrect decision is not that bad. Like, just if you can program faster, if you can change your program from one structure to another anytime you want, then it's not that bad if you pick the wrong structure. It's like, okay, I saw what that was like. I don't like it. Let me go change it to something else, right? How do you get faster? You sit down and do the work until you get faster at doing the work. Like, it's literally the solution to every problem in programming is sitting down and doing the work. The only thing that isn't the solution for is burnout. In burnout, you should get up and not do the work for a while. But for literally everything else, you sit down and do the work. Actually, also getting a girlfriend, sitting down and actually no, because long-term strategy, sitting down and doing the work will help you get a girlfriend more than not doing that, actually. Burnout, well, if you're burned out, just don't pretend you're not burned out. Just go take a vacation. What about a prolonged period of burnout? You just have to let it pass and do your best thing to get over it. But the worst thing you can do for burnout is to kind of lukewarmly force yourself to kind of work a little bit when you really don't want to work. Because then you don't get rest, you don't get relaxation, you don't get to be happy. So you're associating more negativity with sitting there in front of the computer trying to work, which is exactly what burned you out in the first place, right? If you had a happy time every time you sat in front of a computer and thought everything was great, you would never burn out. That's just not what burnout is. So you just have to accept that burnout is happening and go deal with it by not programming. How do you know that you're burned out? I mean, if you feel depressed every time you sit down in front of your computer to do anything, you're burned out. So was I ever burned out? I was very severely burned out from about 2001 to 2004. And a little bit in 2008. Actually, probably from honestly, from 99 to 2004. 2000 to 2004. Okay. So, well, we ran this test. We're setting up this stack. You know what? I'm just going to put a little bit more of a check in here. Assert again, like we did in the other case, I'm just going to assert that the thing we're about to pop is the one that we think it is, right? When things are this dead simple, it's probably not ever going to go wrong, but we're just making sure. Okay, great. So well, since we only do this in one place, I'm not even going to make a function for it. Emit remove. Yeah, okay. So we want to find the emitted for. Okay. So we're going to get this stack. Yeah. Greater than or equal to 0. Okay, so we're going to say is it emitting? It's emitting usually, right? Emitting array for emitting. Okay, so here we're just going to say if asked for is equal to emitting for asked for, then, whoops, let's just give this a short name, E equals, right? We could do a for loop here, right? I never do this kind of loop anymore, so I'm kind of allergic to it, but we might as well do it, right? Okay. Then emitting for equals E break. All right. So then assert that we found a thing. So that's all. Put our comment here. Find the emitting for. So we can get list value and index value. Okay, great. Boom. Okay. Then so the reason I'm just asserting these now is that the next step is to just change these assignments to get it off of this structure, and then we're done. So yeah, we're going to see if that actually goes. Seems like it will. So I get to scribble this off the list. Ba-boom boom. A ding-a-dang a ding-dong. A ding-a-dang a ding-dong. Okay, so here I'm now going to go, I believe I can delete these, which was the whole point of all this. And then we take out all the references to it. So here we say list value is this ting-tangler. All right. We say this is this ting-tangler. Let's check that this, oh dang. Oh, that's the same. All right, this is our Heisenbug again. Yeah. That has nothing to do with what we're working on. It is a bug that I have to fix, but we are not doing that right now. Let's just change these to value number. All right. So this one, this was us just storing this back when we're emitting the for loop. This one just goes, bam, you're gone. And then similarly here, this one just goes. And that's it. Except we can't finish building because this is running the executable. All right. Great. Whoops, no. Run. Okay. That's great, everybody. Now we have a compiler that did exactly what it did, except differently, except no one can tell. It's our little secret. Look at these nice round numbers of how many lines. Look at that. Okay, so I think I warm up some more tea, and then we could look at the case statements. Because there's two more things that we saw in the header file that have this kind of relationship with the bytecode system. Lambda body had a little bit, but honestly, not that worried about it because it's going to get handled by a different thing. But the case statements are kind of like this, except they're kind of complicated too. So we're going to want to look at that. Anyway, why don't I commit this? Let's make sure we didn't somehow make something incredibly slow, right? I mean, we're streaming, so we won't get peak compile speeds, but we should get okay speeds. All right, 0.77, 0.75, 0.78. I guess that's about what I expect when streaming. I'm not sure. Because I get about 0.65. I wonder if there's been a speed regression somehow. I don't think there would be. I don't feel like there would be. I'm not thrilled by this number, but again, when we're streaming, it's like all bets are off. We're like running Epic Store and Discord and like all these junkers. Oh, you know what? I bet. Hold on. There's this thing that happens where like Radeon drivers, which like why are those even installed on this machine? Because it's an NVIDIA machine. Or no, it's a monitor. It's monitor driver. I don't know. Let's just check that. Yeah, Asus ROG Aura service. That's what's happening. It's like eating an entire core. Yeah. All right. And then Windows command process. Why is Windows command processor? Is that just one of the shells that Visual Studio launched? Like what's going on there? All right. So OBS taking CPU, that's fine. Chrome taking CPU. I'm going to close all my web pages, or most of them. The thing is, I'm keeping these web pages open because maybe I want to know, but somebody's freaking mining Bitcoin. We won't worry about it. Let's just see. It's not that much faster. Oh, there we go. 6970. Yeah, so we're posting like 50 milliseconds faster. This is more like what I expected to see. And then it's like 6.5 if I'm not streaming. I don't have Chrome eating half a CPU. Okay. So we didn't introduce anything drastic in terms of speed regressions. Firefox or Brave? I tried to use Firefox and it was so goddamn slow. I couldn't deal. I tried in the mid 2020, late 2020. I just couldn't do it. It was so bad. Anyway, that's good. Okay, I'm going to warm up some more tea. Are there any questions about what we have been doing? Technical questions, please. Oh, did we commit this? Did we commit? I think we did. Yep. Questions, questions. Any questions? Any questions? Did you get screwed by dumping 700 into Star Citizen? I don't know. Do you feel $700 worth of entertained? I mean, don't like baseball game box seats cost $700 or something back when we had baseball games in stadiums? It's all subjective. Did I ever plot compiler lines of code over time? No, but that's something you could do because you could just dump the source control at various moments in time. How much time it took to write the first version of the compiler that you showed in the first demo? That was like, I don't remember exactly. That was like sort of probably 6 weeks of work or something. But not really full-time work. Like it's very easy to make a demo compared to making a production quality final thing, right? So with the demo, I was just like hyped with the progress I had. Is there some good application of ML in compiler building? I think ML in program visualization could be good. I think using machine learning to guess at what optimizations might be a good idea to try would be useful. Yeah, so the first 2 talks that I did, like if you go on the YouTube channel, there's 2 talks that I did before I had any implementation of anything. And then I decided to work on it. And so whatever the distance was between the second talk and the third talk is, I think, is how long I was working on it. But I was also doing the witness, right? So, After what amount of time did I ditch compiling to C? So the first backend we had was LLVM. And I think that was like around the end of 2016, early 2017. Maybe we ditched C in 2017, probably. I don't know. Yeah, we did start by generating C. Yes, yes. What do you think of using C as the backend being the permanent solution? No, that would be horrible. That would be horrible. Programming languages that output to C are not really real programming languages quite yet. Because the problem is, look, because you can't make any fundamentally different decisions differently than your underlying layers do, right? Your underlying layers determine what constraints you are subject to. Do I think there is or there could be a programming language objectively superior to all others? Probably not. What sort of tea? I'm still slamming the hot cinnamon spice tea like there's no tomorrow. I drink so much of that stuff. And have for years, dude. What would I do if I started programming today? I probably would think computers are disgusting today. No, I don't know. I don't know. What do we compile into? We compile into the future. I never learned APL, no. I have learned quite a few programming languages in my career. APL was not one of them. I have not really written up OS ideas, but I do have plans for probably a speech that I would do sometime that would include some of those ideas. Okay. So, the condition, basic block, and body, I think, yeah, that's byte code builder. Right, and those are used for jump statements. Now the thing is, so these case statements can have integer indexes on them. Because I don't want to have to make like a big ass hash table or anything. When we do this if in the type checker, you know, when we search for complete and all this stuff, we have to iterate over all the cases. So I should look at that and see if it's easy to assign an integer index to this. Because once we do that, then once we have an integer index coming in, then we can just have an array of these. We can be all Mike Acton about it and have arrays of these and arrays of these, and then we're done. I think. I mean, depending on, like, see, these are all in the same routine. Like, I think we only need these internally to some bit of code. So I think that's pretty easy. So let's see if we can assign serial numbers to these. But I don't want my tea to oversteep. So maybe in 1 or 2 minutes, remind me. All right. So I'm going to say S32 serial number within if, within owning if, because we call it owning if right here. Used by bytecode builder to create state arrays, for example. Could be used by anyone, but, and we're going to set this to -1, actually. Okay, so if it's a switch statement, we iterate over all the things. Oh, this is expression returns on all paths. That's not really where we want to do it. Let's look for a different one. So we could just keep a counter on owning switch and set it here. We could set it bottom up here. Actually, we say inferred cases. So this can just be in our index. There we go. That gives us a good, so there must be an inferred cases dot add, right? So owning switch serial number within owning if equals, no, not owning switch, case serial number is equals owning switch inferred cases dot count. Okay. So that's fine. That's really all we frickin' needed. So when we're in bytecode builder and we're in some of this code that's like, that's for a while loop. Here, where we're dealing with cases, right? We could just say assert case serial number within owning if is greater than or equal to 0. And then we'll just run that. So as long as this is set to a positive or non-negative integer, we're good. As far as I know, we can just use that. So we're just making sure for all the test cases that this is true, and I'm going to pour my tea. What do I think of the move toward writing functions more purely as a general rule? It doesn't make sense. It's a nonsensical religious belief. In the following way. Pure functions are good. I agree with that. Pure functions are good because they're not complicated. You don't have to worry about state. You don't have to worry about interactions with the state and all that. So yes, like if you can do something as a pure function, go ahead and do that. But like, the nonsensical assertion is that you somehow magically could write a lot of things as pure functions that you somehow couldn't have before you had that idea. And I don't think that's true. I think if you're naturally trying to make your code as simple as possible, there will be some stuff that's pure functions and that's great. And there will be some stuff that's not. And you should just try to make all those things as simple as you can. Now, what happens is people get in this mode where they become religious about something like this, and then they just try to factor things into all sorts of pure functions. And then you actually have more functions than you need, and you have like this obfuscation that takes place where you factor stuff in weird ways, and that just makes code harder to understand and complicated again. So like what I don't understand is why people think like, yes, it's useful to notice that pure functions are good and easy to understand and easy to work with. I don't know why people think that some magic therefore happens that lets you change your program, right? Like that's the part that's weird. Like, weren't you already trying to make your program simple anyway? If you weren't, that's the problem, right? If you were, didn't you get a lot of pure functions anyway? Or not even a lot. Didn't you get pure functions where appropriate anyway? Okay, anyway, so we did this. This succeeded for everything. So now, instead of storing these, we can put them elsewhere. So, and in fact, I think all of these are only used locally to this frickin' function. So literally, these don't even have to be on any longer living data structures. They could just be like on the stack, right? Let's see. Let's verify that. So again, this is different condition basic block, but here we go. So this is in emit switch. So we have condition basic block, condition basic block, condition basic block. Okay, so we're down here, and then nobody else in the file says condition basic block. So we're in emit switch. Yes. Okay. So we're going to say serial is this. I'm being serial. Okay. So we have condition basic block, and then what's the other thing? I guess I could look here. Body basic block. I'm just going to make all these arrays. So array. I mean, should I just make 4 arrays? That's a little bit gross. No, it's fine though, because we're going to size them all at once. Array BC, go to if false source, array BC, go to after body source, array basic block, condition BB, array basic block, body BB. Okay, so okay. Go to after body. Body BB. All right. So that's kind of that. This could instead be one array with 4 things in it. And maybe that's a better idea. I'm not going to worry about it right now. Okay. So condition basic condition BB sub serial. I'm being serial. So the other, I'm just going to change over condition basic block. The other arrays we're not even going to use right now. Do we have serial? Wait. This is another case where it's like, do we even need this? Hold on. Yeah, we do. Okay. So this is going to be, let's go back up here, didn't I? Yeah. Okay. This is going to be just this. Again, we're using it locally here so that we just don't have to worry about it. Okay. Condition basic block. Okay, so down here, this is going to be condition BB, first non-default case serial. Serial. I'm being serial. And then we have another loop here, right? Yeah, still in the same function. So this is like a second pass. Whoops, I went back too far. Okay, so condition basic block. Okay, so condition BB of case serial. I'm being serial. We literally only ever want the index. Oh no, I guess we want it there. Okay. Oh great, there's a car alarm. I love car alarms. They're my favorite. Oh, right. It's not called arrow serial. It's called serial number within owning if. Ugh. Let's just call it serial. Not serial alf alien life form. All right. We're just going to go. You know, I like the long names, but sometimes I don't like the long names, you know? Okay, will it blend? Wait, that was release build. That went too fast. We want debug build because that... Oh, we're making the release compiler. So that was fine. We want debug compiler, though, just in case it asserts. But it's being serial. It's totally being serial. Okay. So that's great. Body basic block. Hold on. That's for for loop. That's like a different thing. Yeah, so this variable has more resemblances in different places. Okay, so this is case statement. So body BB serial. All right. Wait. I just wanted to make sure, because this is case and then previous case, I wanted to make sure I didn't accidentally delete previous case or something. All right. You know what? Again, if we're going to use case arrow serial a lot, so it just, when we have these double nested things, it's just going to be a little easier to read. It's going to make it easier for us to be serial. Not too much easier though. Okay. I'm a little confused, but like we're linking both ways for the last case. I don't know. I'm sure I thought about this and it's all very correct. Probably not. Who knows? It looks to me like I'm anyway. Oh, right. Link both ways is not exclusive, right? You can link because it's just successors. Link both ways means add to successor list, and there can of course be multiple successors. What chip would I rather use? Probably ARM64, but I don't know. I don't know that much about ARM64. I know nothing about RISC-V. Who knows? Maybe I would like RISC-V. You wonder if I had msearch in my Emacs. No, I am not going to bother messing with Emacs at all ever anymore. Basically, at some point, I will find another editor that's worth using, but I cannot invest in Emacs. It's just terrible. Okay. So we're good. I believe I already deleted those members off Ast, right? Oh, I didn't. I'll put this note just at the top here. Oh no. Oh, I didn't do the go-tos yet, guys. You know what? Let's delete these and make sure we build, and then I'll just check in, and then we'll do the go-tos. Because the go-tos, same thing as what we just did. In fact, we already laid all the groundwork. We have the arrays. We're just going to do some things. So now we do the go-tos. Okay. Serial. All right. All right. That's literally it. Dang it. Okay. So here, we are not initializing these arrays at all. And here we actually test to C. So we're going to have to initialize this. Okay. Now it could be that that's not actually necessary and that we hit things in order. I don't frickin' know. Okay. What's wrong? What's wrong, baby? U32. Oh, yeah. I hope I didn't screw that up. I can't believe it's only been 3 hours. It feels like a much longer stream, I hate to say. But we've gotten such good cleanups done. All right, well, I mean, that is all the major bytecode system clean. Now, there are equivalent things that I want to do for other systems, for sure. Like, let me write them down. So there's, there's FFI. That might be easy. I don't know. There's global data. Ugh. That one's going to be gross. There's export or type info. Message export. Backend. So any of these individual systems, progress can be made on similar to what we're doing here. It might be more annoying and gross sometimes, hard to say. But then at some point, enough of this has been done that it's less of a gigantic mess to try to do this eventual larger refactor, right? We're doing smaller refactors to set the stage for someday a bigger one. That's all. That's all we're doing. Stuff on Ask Lambda. Yeah, well, like I said, we're not going to do stuff on Ask Lambda today, right? That's going to be like a different thing. So there's this bytecode pointer. That's the main thing. And that's not really, what I would say is that's actually not really a bytecode system problem, because we probably don't say lambda arrow bytecode very much there. And if we do, it's actually pretty easy to get rid of. This is more of like a backend thing, because what happens is the backend gets the lambda and wants to look at the bytecode. Actually, also the bytecode runner. That's another thing. We'll put that on the list. Anyway, so like we could see if that happens, but like I feel like aside from, I mean, this is not a perfect search by any means, but like here we say lambda bytecode, but this actually could be current bytecode. This assigns it because we have current bytecode as like a global variable. That's one thing I could do is let's make sure this finished. So we could do that. It's just my butt is feeling like it's been in a chair contiguously too much, and I kind of want to move around. But we could go here. Like this is just current bytecode. I almost guarantee, because this is where we set it, but that's really for the benefit of other systems. So if we had a serial number on Lambda or something, we could just associate it there. The problem is we don't really want a serial number on Lambda because you don't want to serialize, because the whole point is to parallelize eventually. So like maybe there's just like a hash table where you look for it or something, and that could be locked. I don't know. Maybe there's multiple ones. Who knows? I'm not that worried about that. So that's really about the back end. This is sort of, this shouldn't happen. I don't think. We'll check that. Add empty bytecode. So let's just return it from here. And then we don't have to reference lambda arrow bytecode. So it does set it to lambda bytecode, but there we go. Okay, so see, all of these are like needless. We just made gains right there. Made gains right there. Oh, no, this is not, okay. This one, I'm pretty sure this can only happen for the current procedure. Let's see. So we want to change that. I think we could just say current bytecode, but I'm not sure, which is why we're checking this. This is like checking for duplication, which this is just something we would change when we change where this is stored. It's like the bytecode of one lambda, the bytecode of the other lambda, see if they're the same, which, by the way, doesn't actually get called. And that's actually it in this file. So maybe this assert will go off as well. Like I'm not sure why we would ever call this twice with a lambda that's already built. I actually know for the very early versions of the compiler why we would do that, but that stuff is hopefully all fixed and much cleaner. So hopefully these asserts don't go off, although they might. It's not too surprising if they do, but hopefully they don't. No, they're not. Okay, so that's good. Again, we're not going to get rid of 100% of these because we don't have a new place to store this. But maybe that's a thing to do on another stream later on, is just like make a hash table or something that stores these? Question mark? We could look at, like, does it make sense to have just one hash table for bytecodes? Or is it like there's a bunch of stuff about lambdas that all lives together? Okay, well, neither of those went off, so that's great. So here, actually, we don't even need to assert this because add empty bytecode, when it assigns it, can do that assert, right? And then whatever this turns into, if this becomes put this in a hash table or something, then it's like, well, make sure it's not in the hash table if you're in debug build. All right. I never use this debug name. Anyway. Oh, well. Okay. So we're going to assert lambda as current lambda. Therefore, we can use current bytecode. Okay. So we got rid of that lambda arrow bytecode there. So literally, it's just this thing that sets it, and then this thing that checks for duplication. And that's it in that entire file now. Right. Now, actually, I should maybe check. Yeah. So you can see there's stuff in the backends that use this. There's like pipe stuff, debug info stuff. But anyway, so in the backends are sort of doing one lambda at a time. So they could do a current bytecode thing. Like they basically, if there's a hash table, they want to look something up once in the hash table and then hold it around, right? So we could do that one backend at a time and stuff. And in fact, I mean, we could do that without it being a hash table, right? You could just say, okay, we're going to store the bytecode in current bytecode. We're not going to refer to it through the Lambda at all. And then you go do the hash table later, and then you only have to change like one or two little things, right? There's arts to these refactors that make them much easier. Okay, also much cheesier. I just want to look. I did a bunch of searches for Lambda bytecode, but I'm just going to go arrow bytecode. Yeah, it's the same. Okay, great. Okay, that was cool. That was productive. Most Lambda bytecode in bytecode builder. So I think it's time for me to take a break. And maybe we'll do this on a stream later on. Maybe I'll do it off stream. Who knows? But that, this is good. Oh, yeah. So just I like sometimes to give myself a little bit extra for my subconscious to think about. And so that question is like, hey, what are the things that we maybe want to organize that's back-end kind of stuff, right? So it's bytecode, LLVM, Lambda module. I'm just going to put them all together here. Like the link to body is like, well, that's still a front end thing. What's stack trace linear allocation? That's for the purposes of running things. Lastly, though, guys, maybe we actually don't want to split this off. Maybe we do. Okay, so here's the thing. There's part of this Lambda that's a syntax tree part, and there's a part that's like the back-end work part. So maybe I say there's one struct for the back-end work part, and it just has all these things in it, and you just look it up in this hash table when you want it. Maybe. Or maybe it's more atomized than that. And like, here's the hash table of the bytecodes. Here's the hash table of the backend stuff. I'm not sure which of those is best. I'm inclined to just break this off into one chunk for now. But we'll see. But I'm not going to do that at all yet. I'm going to take a break. My Pomodoro method says it's time to take a break. So it's been 200 minutes, although we did just chat at the beginning of the stream for a while. But that's a pretty good, like, 3 hours is kind of okay. Let's just double check. Let's do, oh, we are in release build. Uh-oh. I hope I haven't been doing the test debug build thing. I might have been building release and checking debug for a long time. So this is great. This is a roadmap toward factoring things apart. What time do I usually start back up? I don't have a regular schedule. I just kind of stream. I might. Okay, I'm toying around with doing some unusual content stream tonight. We'll see if that happens, like after an after work hours stream. We'll see. Maybe I'll just program some more. Not a hot tub stream, but something. We'll do something. All right. I'm just going to sign off without rating anyone. because that takes effort. Thank you, everybody, for coming by, and we'll do something again pretty soon.